Q8091. During the inspection of an engine control system in which push-pull control rods are used, the threaded rod end should A. Ensure that the safety wire passes through the hole and shank of the rod end. B. Be checked for thread engagement of at least 2 threads, but not more than 4 threads. C. Be checked toward the amount of thread engagement by means of the inspection holes. The correct answer is C. The first claim is untrue. Pre-ignition is the ignition of the fuel-air mixture earlier than the usual ignition is scheduled to take place. It is brought on by flammable materials inside the cylinder. Carbon particles may become incandescent and ignite the mixture early as a result of detonation because detonation generates enough heat in a cylinder. The second claim is untrue. Detonation is the unburned charge's spontaneous combustion in advance of the flame front following ignition. Pre-ignition can make the fuel-air combination burn in the cylinder for a long enough period of time to raise the unburned mixture's temperature to a critical level. It no longer burns, but bursts at this moment. This sudden release of energy has the potential to overheat the cylinder and generate enough pressure to break the piston and connecting rod. Q8092. Which of the following conditions would most likely lead to detonation? A. Late ignition timing. B. Use of fuel with too high an octane rating. C. Use of fuel with too low an octane rating. The correct answer is C. The octane rating of fuel is a measure of its resistance to detonation. Higher octane fuels have greater resistance to detonation, while lower octane fuels are more prone to detonation. When an engine is operated with fuel that has too low of an octane rating for its specific requirements, there is an increased likelihood of detonation occurring. Option A, late ignition timing, can contribute to pre-ignition but is not directly related to detonation. Pre-ignition occurs when the air-fuel mixture ignites before the spark plug fires. While late ignition timing can lead to overheating and other issues, it is not the primary cause of detonation. Q8093. An supercharged aircraft reciprocating engine, operated at full throttle from sea level to 10,000 feet, provided the RPM is unchanged, will A. Lose power due to the reduced volume of air drawn into the cylinders. B. Produce constant power due to the same volume of air drawn into the cylinders. C. Lose power due to the reduced density of the air drawn into the cylinders. The correct answer is C. The weight of the air that is burned along with the fuel determines how much power is generated by an aircraft reciprocating engine. The weight of the air per unit volume is less dense at altitude than it is at sea level. As a result, a non-supercharged engine will produce more power at the same RPM by requiring less weight of air to mix with the fuel. Q8094. Which of the following would most likely cause a reciprocating engine to backfire through the induction system at low RPM operation? A. Idle mixture too rich. B. Clogged derichment valve. C. Lean mixture. The correct answer is C. In comparison to either a rich or a chemically right ratio, a lean fuel-air mixture burns more slowly. It's possible that a lean mixture will continue to burn while it's forced out the exhaust valve. The fresh fuel-air charge being introduced into the cylinder through the intake valve during the valve overlap period can be ignited by the burning exhaust gases when both the intake and exhaust valves are open. The induction system may have a backfire as a result of this. Q8095. How may it be determined that a reciprocating engine with a dry sump is pre-oiled sufficiently? A. The engine oil pressure gauge will indicate normal oil pressure. B. Oil will flow from the engine return line or indicator port. C. When the quantity of oil specified by the manufacturer has been pumped into the engine. The correct answer is B. In a dry sump system, the engine's oil supply is stored in an external reservoir, the dry sump tank, rather than in an oil pan within the engine. During pre-oiling, the The oil is pumped from the reservoir into the engine's lubrication system to ensure proper lubrication of the internal components before starting the engine. To determine if the engine is pre-oiled sufficiently in a dry sump system, one method is to observe the flow of oil from the engine return line or indicator port. As the oil is being pumped into the engine, it should start to circulate through the lubrication system. Once the oil reaches the return line or indicator port, it indicates that sufficient oil has passed through the engine and is returning to the reservoir. This suggests that the engine is adequately pre-oiled.